Thank you very much. Thank you very much. Good morning. Ohayo gozaimasu. I will be introducing Professor Kimura, our professor from Kyoto University. Yeah, I think Kyoto University. And also Professor Emeritus of Kyoto University in Japan. Thank you, Professor, for making time. Yeah. Thank you, Professor, for making time. You will be flying right after the presentation, so I'll make this short. Thank you. He's a researcher in mechanical behavior of structures, foundation, tunnel, reinforced soil, new mechanical materials, environmental geotechnics, and so much. He has published more than 100 publications, and I cannot list them all today. So thank you very much. I would like to invite Professor Kimura to the stage. Thank you.
Thank you very much for a nice introduction for me. Today's my presentation is a new technology thinking from a different angle. This is very important things. Ordinary thinking way is not enough to make an innovation. So the thinking from the different angle, very different angle, and reach to the the new technology is a very important thing. And I'm a civil engineer, and my research, the main research topic is geotechnical engineering. It means I research the soil or rock. Okay? Foundation, tunneling, retaining wall, new structure is my research field. But I'm a little bit unique because I'm a little bit young, but I have already retired Kyoto University. Now is a professor emeritus Kyoto University, but used to be a Department of the Civil and Earth Resources Engineers professor. I retired 2 years earlier. Why I retired 2 years earlier? Because Japanese, the professor salary is very low. Oh, it's true. Yeah? So I shifted from the university to public sector. So the public sector to university is common. But the university people is very few to go to the public sector when after 6 years old. But I become a managing director. Maybe I will become the main director or chairman of the small construction company. The name is a Bond Engineer, Osaka, Japan. But I'm very unique because I have already have some another job. It's the chairperson of board. NGO. The name is a Community Road Empowerment. So if I have a time, I can introduce my NGO's activity. Okay. It was me, about 40 years ago. I crossed Sahara Desert from Alger to Niger. The distance is about 3,500 kilometers. So I make a group and I cross Sahara Desert with this bicycle. You see the backside, we can see some camel. I have already traveled 285 times, and 92 times I came to Africa. And Africa have 56 countries, but I have already traveled 23 countries. Why the civil engineer professor need to go to Africa? I can explain later. I have already been to the 87 countries. You see, it was me. Huh? Nowadays, after 20 years old, up to the 20 years old, I growing vertically. Huh? After that, I growing horizontally. You understand? It is the African woman's way. Maybe the man's is also. Today's topics is a little bit, complicated because, I'm a civil engineer, some, the special talk. But, ordinary case, when we make an elevated, the structure, highway or some railway, we need to make this kind of, the pier. Beneath the pier, we need to make some foundation. Foundation having this footing and some pipe. If the soil is very weak, we need such kind of pipe. Pipe diameter is 1 meter diameter, length is sometimes 25 meters, but in Japan, some area is 90 meters, deep. Because we, piling up the very soft soil. So this kind of, the foundation is my major, the researching topics. This is a concrete, the pier. If we use a, steel pier, we can reduce the size of the, the pier. But my new, the technique is more slender, like this. Only using, the 4-pile, and 4-pile having some, the shear panel, and without the footing, and this, the pier pile become, the foundation pile. So I just explained what kind of things we need to do to, the construct this kind of, the new technology. This is actual, the construction site already, the constructed these kind of things. Seismic performance of the bridge column integrated by the multiple steel pipes with directly connected pipe is the new, the technology's name. So you see, this is the Kobe earthquake. After Kobe earthquake, this kind of elevated bridge, concrete elevated bridge, falling down. Because at that time we did not expect very huge, the earthquake force. And also we changed the design, and nowadays we can bear the very high, the high, earthquake. This is a destroyed, the pier. Sometimes, the bridge, the floor falling down. Many people die. So in 1995, many structures collapsed by the Great Hanshin Awaji earthquake in Japan. Before the earthquake, it was a mainstream to design the structure so that it would not break. It would not break, so we can make a good structure. But after Kobe earthquake, Japanese, the designers think, actually more, the bigger earthquake force happened, it will break. However, we realized that it was impossible to design a structure that would not break. So how to do? It is necessary for us to design the structure assuming being broken. So once we make this kind of structure, but this force level, this structure is okay, safety. But after the 2 times, 3 times more bigger the force applied, this structure destroyed like this. So I wanted to estimate what kind of the break behavior. It is very important things. So the new technology thinking from the different angle is ordinary case. Upper part is a pier, and under the ground we make this kind of footing. So the footing is supported by the many pipes. That is the ordinary case of the pipe foundations. Okay. So the Japan have experienced a big earthquake, but Ethiopia, Addis Ababa, maybe few earthquake. Once the Ethiopian, the Addis Ababa have a Kobe earthquake, every building destroyed. At that time, you can make a more good city, yeah, after that, yeah. But you are very happy because you do not have a big earthquake in Addis Ababa. So our, the thinking way is that without footing, it is possible to bear the some, the superstructure force. So how to do? This is the some, the technique we call the integrated column by the multiple steel pipe, developed in 2004. A bridge pier integrated by the 4 steel pipes and multiple shear links. These multiple shear links, the supporting. So it is designed based on the damage control concept. We have the big earthquake. The pipe is the alive, but this the shear panel destroyed. After the earthquake, we only replace this shear panel. That is a more economical the way for this kind of elevated bridge. The shear panel are made of the low yield stress steel and have the energy dissipation properties. So intended the seismic damage into shear panel, only shear panel. So the structure is completely different. This is a superstructure, this is the foundation. Ordinary foundation having this footing and 3 multiple 3, it is a 9 pi. But my new proposal, the foundation is using the grand beam and only 4 pi. This the elevated bridge structure and this structure behave almost same behavior. So at that time, which structure you use? Maybe the people need to use this structure. Without footing, rational foundation, and reduce inertial force and sectional force. This is a little bit complicated, but we can, if the construction line is very narrow, this the space is very narrow compared to the footing case, so that we do not use a big land to constructing the elevated bridge. So engineer, we need to do some the experimental test. This is a 1/20th scale of the the actual size, and we preparing the 2 meters pipe and 1.5 meters the superstructure and panel, make a panel. This is with footing, without footing, and put this kind of structure in the soil chamber, and this is the equipment. So this soil chamber is 6 meters wide, 2 meters wide, and also the 3 meters the height. So that we prepare the 2 same chamber and put the different structure and put on the shaking table. Have you ever seen the shaking table? This shaking table is very common in Japan. 6 meters table. But on the table, we can experience big earthquake. We call that such kind of table is a shaking table. We make an acceleration and check the behavior, how to destroy. So this is a footing type. This is without footing type. Ordinary case, footing type is a very rigid, but without footing type is a little bit the flexible. So this is the first step, the acceleration, second step acceleration, third step acceleration. So footing type structure destroyed within 3 steps acceleration. But more flexible type, the proposed method, the bear up to 8th acceleration. Maybe the acceleration, the force is more than 4 times. 4 times, the acceleration, we can bear this simple structure. Because change the mind and without the footing, at that time that we can change the structure. Maybe the complicated things is just jumping. So I only do the 1 full scale, 1/20 scale the test. Many people say, oh, if we apply the different frequency, different earthquake level, what kind of behavior they show? So, at that case, we need to do these, the trend are influenced by the frequency and damping property. So we change the frequency, acceleration frequency and damping ratio, and doing such kind of test in an analytical model. 3-dimensional analytical model we use and make a the more the safety structure. This future work is about 8 years ago. We have already done this kind of the analytical things. Nowadays, it is possible to construct this kind of structure. So the price is less than 30%, 35%. ordinary structure is this kind of structure is the one. This the proposed structure is only 65%. We can reduce the construction cost. Okay, many people are not interested in the civil engineer, so I just explain some important things for innovation. So ordinary people thinking the PDCA. P is a plan, make a plan and do and check the such kind of the result and action again. So the action, plan, make a plan and do something and check the behavior and action, reaction and do, plan and do. This kind of the PDCA cycle is a very important thing. People say, but my thinking way is a QPMI is a very important thing. What is a Q? What is a P? What is a M? What is a I? Previous keynote lecture, Professor Mekonen introduced us. Passion is very important. Hard work is also very important, and don't give up is very important things. This is a very important thing for the PhD, the student or another researcher. I wanted to put another essence. Most important things is a question. How to reduce the CO2? How to make a strong structure? How to control the water? How to prevent the desert? Such kind of the question is a very important thing for engineer. So that these universities, the student or the lecturer or teacher or president need to every time need question. If people have a question, next the things is a passion. Have a passion and doing the research and doing something only individually. If the people doing such kind of things become the mission, and finally such activity become innovation. Innovation is not fast. Question, passion, mission, innovation. This is a very important thing for my keynote speaker. I came here, it takes 1 day from Japan to Addis Ababa. I stayed 2 nights, and after 4 hours later, I need to fly back to Japan. Anyway, this question, passion, mission, innovation is very important things. So I just introducing some interesting, the technique Japanese, the young people made. Such, the company is a Spiber. So the Spiber's young, the president talking, he is only 35 years old, very young. His, the thinking way, the initial stage is an iron stage. Next stage become a plastic stage. So, third stage is a fact. Protein. Protein is a very important thing. For example, this company, introducing the spider silk. The hair's diameter is only 30 micrometer. But the spider silk's diameter is a 6 micrometer. Very thin, but very strong. Many people think this kind of way. If we can correct the spiders, the silk, and if we make, some crosses, such crosses become very strong. But it must be very difficult for collecting the spider silk. Looks funny, yeah? So, this man thinking this kind of way, what kind of, the protein is a main protein for strength, this kind of fiber. So, they check such kind of things and think this kind of way. Okay, some, the bacteria will make this protein. So that they collecting the findings of some bacteria to producing the spider silk protein and make a big factory and making the spider silk. Nowadays, some European companies, the clothes, the company, North Face, producing the spider silks clothes, very strong. Another Japanese case, TBA. Such company, is very, very interesting because Limex is some special material, is mainly made from the limestone. So from the stone, they producing something. Paper. From stone, they produce the paper. At that time, they do not use the timber. If you need to make a 1 tons paper, you need a 12 tons, the tree, timber. And also the 100 tons water you need. This auditorium room is very good. I went to the toilet, but the toilet does not have a water. Water is a very important thing even in Ethiopia. So when we produce 1 tons, the paper, we spend 100 tons water. It is a boring thing. So this company making the stone paper nowadays, the introducing stone straw or such kind of things. So what is my QPMI? I can introduce my QPMI. So the problem in rural area, cause for the poverty is one, the very important thing is agriculture community cannot transport agricultural products during rainy season. Okay? So the crops are spoiled and cannot get money. So main road is, the paved. Okay, World Bank paying some amount of money and paying from the city to city. But rural area, Ethiopia is a farming area, so the rural area's road is unpaved. Maybe the 80% is unpaved. Once the rainy season comes, now rainy season will come, at that time the road become very, very muddy. It is impossible to pass. Sometimes, the people pushing. Solution is only pushing. Pushing the car is a solution. It is not interesting. So I make a question, how to, improve this kind of unpavement road with some technique, engineering technique. Ambulance can stuck. So how to repair rural road without any machine, without using any machine? It is very important thing. In rural area, with machine is not interesting. So what can I do for rural people as a civil engineer? Challenge and good solution. This is an example. September 2007, I went to the Uganda, east part of the Uganda. This small pothole became a bigger. 20 years later, finally, whole section of the road became a pothole. At that time, the 200,000 hectares rice field is impossible to carry rice to the market. So I'm using a small, simple technique, and repair with village. Simple technique can carry. Now I'm carrying simple technique. I show you. Such kind of road is only one day is 50 car per day. How to repair? Using a simple technique. Simple technique is a plastic bag. Put the soil inside the plastic bag and make a compaction. At that time, we can make a good base course. Oh, this is a low tech. But sometimes high tech cannot use. Nanotech cannot use to repair the road. This kind of low tech sometimes can repair road. Okay? So that you get this kind of technique, okay, you know the introducing another technique. We call this kind of, the bag is a geospace soil bag. We call dono bag. Do is a soil, no is a bag. Okay? Put the soil inside the bag. Many people think of prevent flood water from going over the dike. But we put the soil inside the bag and piling and compact. At that time, the base course become very strong. This technique is a locally available material, labor-based technology. not to use a machine, labor-based technology, low cost, only 1 meter's road, I can make about 200 bull. 200 bull. 1 meter's road, we can repair. Low technology. People, ordinary people, become a contractor. Huh? Yeah. Compaction. Why I need to go to Africa, 26 country? Because I have already introducing this technology more than 31 countries. Sudan have already, introduced last year. Africa is a 20 country. But make a training is very important things for ordinary people. Length is about 221 kilometers road I have already repaired in the world. But the number of the trainees is 21,000 people have already get this knowledge and they prepare their road by themselves. So charity to the job creation is, the contribution for the starting businesses. Nowadays, the villager make a business. Japanese government or international organization, the support funding to our, the NGO, and we transfer the technical to the association. So such kind of, the group of the rural agriculture group or rural, the young people group wanted to make some small construction company. After make a construction company, the government, the ordering and the design and the construction, and this benefits through wider range because benefit to the community people, improvement of the accessibility, shortening time for travel, decreasing of the transport cost. This is the improvement of the livelihood. I said again, high tech sometimes saves the people, but this kind of low tech will save the people. This is my good the dream for the rural area and pavement road. This is the case of the Tanzania. Tanzania's road is we need this the curve. Once rain comes, rain need to go to the the channel, both channel. So I repair this the bad road with using this donor technology. So people can take a walk. African woman can transfer the some baggage on the head, and maybe the African the papa will go to the some drinking shop because the road is very good. So such kind of benefit we can get. Sometimes the low tech can get some benefit. So I hope this university, high tech is okay, but the middle technique, low tech, combine together and make a good, the country in Ethiopia. Thank you for your attention.